Hi, in this video I'm going to discuss briefly about introduction of the probability with definitions, and then we will talk about the laws of probability, addition and multiplication rule, under which we will talk a little bit on the conditional probability, total probability and Bayes formula. Okay, so first of all, you have seen the probability in your elementary statistics class. Probability is chance of event occurring, right? Experiment or trial is the procedure that can be repeated and has a well-defined set of possible results. And outcome is the result of a single trial of a probability experiment. Sample space is collection of all outcomes in an experiment, right? Event consists of outcomes. An event can be simple or compound. So a simple event has only one outcome, and compound event have more than one outcome. Okay, and equally likely events are the events that have the same chance of happening. Okay, and then probability of an event E is the total number of outcomes in the event E divided by the total number of outcomes in the sample space. Okay, let us see an example that I want to toss two coins together. Okay, so if you toss a coin, toss a coin. This is an experiment. Okay, experiment. This experiment has tossing a coin, so it has only one trial, meaning because you are tossing only once. Okay, so what are the outcomes? The total outcomes, the possible outcomes will be either head or tail, right? So this is the total outcomes in the probability. So this is the sample space S, we denote by S. Okay, so H is one outcome, T is another outcome. Okay, so if you toss two coins together, tossing two coins, so what are the sample space? Then sample space will be either both coin will be head, either or first coin is head and second coin is tail. First coin is tail and second is head, and then both are tail. So these are the sample space. This is the sample space when two coins are tossed together, right? So if you want to find so here there are four outcomes. This is one outcome, this is another outcome, and another outcome. So there are four outcomes here. You see that? Okay. Now if you want to find the probability of something, for example, what is the probability of both head? So if you want to find the probability of both head, so how many total outcomes are there and how many double heads are there, right? So there is only one double head in the both head in the sample space. So 1 divided by the total number of outcomes in the sample space is 1, 2, 3, 4. So 4. Okay. So what is the probability of greater than one head? Greater than one head. One head. Okay. So I'm writing greater than one head. So how many outcomes have greater than one head? So just only one, right? Or if you say greater or equals to one head, so if you toss two coins together, these are the possibilities, that is the sample space. And if you want to find the probability of greater or equals to one head, that means 1, 2, 3. There are three outcomes have either one head or more head, right? So that is 3 out of 4. That's how you find out the probability. How about the probability of no head, right? Zero head, let's say. No head means zero head. So how many outcomes have zero head? This outcome has two head, this outcome has one head, this outcome has one head, this outcome has zero head, right? So there is only one outcome with zero heads, or and divide by the total number of outcome is 4. So this is how we find out the probability. Okay, so you see that we have seen this kind of example in your elementary statistics class. The next example is, if a family plan to have 3 children, list all possible outcomes in the sample space and then find the probability of at least one girl. Okay, if a family plan to have 3 children, then what are the outcomes in the sample space? Either all of them are boys, right? Boy, the first boy, second boy, third boy, or 2 boys and 1 girl, but in different order. So boy and girl. So you can have boy, boy, or girl, boy. Okay, or so you can have 2 girls, that is girl, boy, or the first girl, second boy, third girl, or the first boy, second girl, and then third girl, or all the girls. So these are the possible outcomes. There's only possible outcomes of various order of the boys and girls here, right? So the question is asking, find the probability of at least one girl. So probability of greater or equals to one girl, right? So this doesn't have any girl, right? We should not count that. and this one has one girl, this one has one girl, this one has one girl, this one, so all of these except that one has one girl. So how many have one girl? So how many have one girl or more? That's what it is saying. At least means one, at least one means one or more, right? So how many of them have that? 1, 2, 3, 4, 5, 6, 7. So 7 out of 8 is the probability of at least one girl. Okay, guys. So let us talk about the notes. The probability of any event E is a number, either a fraction or decimal, between 0 and 1, including 0 and 1. So the sum of the probability can be 0, some of the probability can be 1, but all the probabilities are between 0 and 1, including 0 and 1 as well. Okay, the sum of the probability of all outcomes in a sample space is 1. What does that mean? That means if you add the probability of each of those, then it is 1. So because what is the probability of 3 boys? That is 1/8. What is the probability of first 2 boys and third girl? 1/8. Probability of first boy and then girl and then boy is also 1/8, and so on. If you add all those probability of each of those events or each of those single outcomes, then the sum is 1. If an event E cannot occur, then the probability is 0, right? And the complement of an event E is the set of all outcomes in the sample space that are not included in the outcomes of event E. The complement of E is denoted by E bar, or some people also denote by E and then to the C, that is E complement. So this is same as E bar. What does that mean? That means S minus E, right? So in the probability, we usually write for minus, we write like this, S minus E. That means you E bar or E complement is every element in the sample space at S that are not in E. For example, let's say E has 2 boys. So in this example, so what are the outcomes in the event E? So that will be 2 boys means BBG, BGB, GBB, right? That is E. So what will be the E complement then? Everything in S but not in E. That means that will be BBB, okay, GGB or GBG or BGG or GGG. So that is the E complement. Okay, so if you want to find out the probability of E complement, so there are 2 ways to find out the probability of complement of an event. Okay, for example, so one method is the probability of complement of an event is equals to 1 minus probability of that event. Okay, because the total probability is 1 and 1 minus probability of that event. For example, in this case, what is the probability of the E complement will be here in this case is, so there are 3 of them have 2 boys, right? 3 of the outcomes have 2 boys. So 1 minus 3 over 8, because the probability of E is 3 out of 8. So that will be 5 out of 8. So another way is just list the outcomes in the E complement. That is the E complement. So what is the probability of E complement? Just find out from E complements. That is 1, 2, 3, 4, 5. So 5 out of the total in the sample space is 8. So you can do either way. So either way you do, you will get the same answer. Okay, guys. So let us see this example in this slide. What it says is, it says in a sample of 10,000 patients with a certain illness, 200 died within 5 years. So the probability of death is 0.02 and the survival probability is just the complement of death, right? So probability of death is 0.02, it is given. So what is the probability of survival? Is 1 minus the probability of death, right? So that will be 1 minus 0.02 will be 0.98. So this is how we find out the probability of complement of an event. Let us do this example that is in this slide. So if a table of values and the frequencies are given, then to find out the probability, we need to find out the sum of the frequencies. Okay, and then for each of the event, we find out the frequency divided by the total. Okay, let us see this. In a study of 127 patients who needed surgery for fractured bone, the following data represent the number of days in hospital stays. If a patient is selected randomly, find the probability that he stayed exactly 5 days. So what do you mean by that? So number I is probability of 5 is equals to how many people stayed 5 days? 56, right? 56, because this means, so 15 people spend 3 days in the hospital, 32 people spend 4 days in the hospital, 56 people spend 5 days in the hospital, 19 people spend 6 days in the hospital, 5 people spend 7 days in the hospital, right? The first question says that find the probability that the person, if one person is selected randomly, find the probability that the person stays exactly 5 days. So you should be doing this, right? So that 56 over 127 is the total. So that is the probability. For double I, so it says he stayed fewer than 6 days. Probability of less than 6 days. Fewer than 6 means 3, 4, and 5, right? So that will be 15 plus 32 plus 56 divided by 127. If you do that, then you will get 101 over 127. That's what you get. Okay. So the next one is triple I. Is he stayed at most 4. What does that mean? That means 4 or less, right? Probability of at most 4 means 4 or less. That's what the at most means. Okay. So 4 or less. So how many are 4 or less? 15 plus 32 divided by 127. What do you get? That will get 47 over 127. Okay. And the last one is he stayed at least 5 days. IV. At least means what? P lesser equals to 5, right? At least 5 days is lesser equal. Oh, at least 5 means greater or equals to 5, not lesser equals to 5. Greater or equals to 5. At least means 5 or more, right? So that will be how much? So 5 is 56 plus 19 plus 5, right? At least 5 means 5 or more. 5 for 5 days there are 56 people. For 6 days there are 19 people, and for 7 days there are 5 people. Divide by 127. Okay, so that will be 0 plus 2 3 plus 80 divided by 127. So that is the probability of at least 5 days. Okay, so that's the answer to this question there. So let me erase this and then read that the two events are mutually exclusive events or disjoint events if they cannot occur at the same time. Okay, they have no outcomes in common. So let us see an example, because what it says is two events are mutually exclusive if they do not have anything common. Okay, for example, if you roll a dice. So what are the outcome in the sample space? Is 1, 2, 3, 4, 5, 6, right? These are the outcomes in the sample space. So let us say that O is the odd outcomes, 1, 3, 5. Let us denote E is the even outcomes, 2, 4, 6. Do they have anything in common? No, right? So they are the disjoint events. Okay, so O and E are disjoint event. If they have something in common, we call joint event. If they have common, then we call joint event. For example, let us say that A is equals to less than 4. So what are those outcomes in the less than 4 from the sample space? That will be 1, 2, 3, right? So A and E are joint event, right? Joint, you can say that. Okay, because they have 2 in common, right? You see that? A and E. So A has 2 here, E also has 2 here. So they have the common outcome. So it is the joint event. So why do we need joint and disjoint event? Is to do the sum rule, addition rule of probability, and we will do the multiplication rule later. But for the addition rule, we have 2 formula. One is if they have something in common, and the other is if they do not have something in common. Okay, all right, let us see that. When two events A and B are mutually exclusive, the probability of A or B, number 1, A and B are disjoint, mutually exclusive is also called disjoint. Okay, disjoint. If A and B are disjoint, then PA or B is equals to PA plus PB. If the two events do not have anything in common, then the probability of A or B is same as the sum of their separate probabilities. Okay, for example, let me give you the same example we had, that roll a dice, right? If you roll a dice, then the sample space are 1, 2, 3, 4, 5, 6. And let's say odd event is 1, 3, 5, the odd numbers, and even event are the even numbers 2, 4, 6 in that sample space, right? What is the probability of O or E? Do they have anything common? No, nothing common, because there is 1, 3, 5, there is 2, 4, 6, right? In that case, if you want to find the probability of O or E, then you do probability of O plus probability of E separately. You add them, okay? What is the probability of O? How many outcomes are in O? 3. How many outcomes in the sample space? 6. 3 out of 6. Plus probability of E is how many outcomes in E? 3 divided by the total number of outcomes is 6. So that is 3 plus 3 is 6 over 6. That is basically 1. So probability of O or E, odd or even number, is 1. What does that mean? That means 1 is the 100%, right? Because the maximum probability is 1. That is the 100% probability. Meaning that if you roll a dice, then the probability or the chance of happening either odd or even number of dots is 100%, because you will get either odd dots or even dots. Okay, that's what you get. Okay, so another example I want to give you is, and I had given you that. So what is, we were denoting A equals to less than 4, right? So what are the outcomes in A? 1, 2, 2, and then 3, right? So what is the probability of A? Is 3 over 6 as well. But is there anything common? Yes, A, and let's say A and O. If you want to do A and, so if you want to do, for example, probability of A or O, since they have common outcomes, you see that? Since they are joint, then you will have to add PA plus PO, and then you need to subtract the common PA and O. You need to subtract the common part, okay? So what is PA? PA is 3 over 6 plus PO is also 3 over 6, because there are 3 outcomes, right? Minus, what is the common outcome on A and O? So 1 and 3 is common on both, right? You see that? 1 and 3 are common. O has 1 and 3, and A also has 1 and 3. That will be 2. There are 2 in common. So the number of outcomes that falls in A and O is, there are 2 of them, 2 over 6. So what do you get? You get 4 over 6, right? Because 3 plus 3 is 6, minus 2 over 6 will be 4 over 6. That is 2/3. Okay, that is the for the joint events. You see that when two events A and B are not mutually exclusive, which is same as joint, the probability of A or B will occur is PA or B is given as PA plus PB. Here, if they were disjoint, then you just add PA and PB. But if they are joined, then you need to subtract PA and B. That's what you need to do. Okay. So we did that example. So I want to do one more example here. That example is this example. Okay. Let us do this example. In a study related to hair color and eye color, 1200 people have brown, 500 people have black, and 70 have red hair color. 300 of the people having black hair color will have brown eye color, and 50 of the red hair color people have blue eye color. The total number of blue eye color people is 1050. So we need to form a table for the given information, and if a person is selected randomly, find the probability that he has black or red hair, and so on. Okay, first of all, we want to make the table for that. Let's say hair color, and let's write down here eye color. Okay, so what I'm going to do is, there are 3 different types of hair color, right? So what are those? All right, so on the hair color, what are the color of the hair? So 1200 people have brown hair, right? And 500 have black. Another color of the hair is black here. And another one is red. 70 have red. So let me write down red. Okay. All right. So let us put the given things here. So, and how many eye color are there? So brown eye color and blue eye color. There are just brown eye color and blue eye color. Okay. Well, I want to complete that table, and we will do the total also. Okay. Let me write down total, and ready to write down total. Okay, so let us do that. All right. So let us complete the table with the given. In a study related to the hair color and eye color, 1200 people have brown eye color. Where does that, brown hair color, right? You see that? These are the hair colors. 1200 people have brown hair color. So you see that? This is the brown hair color. This column is for brown hair color. This column is for black hair color, and this column is for red hair color. Okay. So the total is 1200. 1200 people have brown hair color, 500 people have black hair color, and 70 people have a red hair color. Okay, now 300 of the people having black hair color have brown eye color. So you see that total black hair color people are 500, and 300 of them have brown eye color. 300 of them have brown eye color. Okay, and then 50 of the red hair color people have blue eye color. So 50 of them have the blue eye color. See, this row is for blue eye color. The total red hair color is 70, and 50 of the red hair color is that. Okay, now we need to complete. Okay, how do I complete that? Also, the total number of blue eye color people is 1050. This is 1050. That is 1050. So these are the given things. Now I want to fill with the non-given things there. Okay, now you see that the total of the red hair color is 70. So how many of them must be here? 20, right? Similarly, total of the black hair color is 500. There is 300. So there must be 200, right? And we see that the total of the blue is 1050. You see that? So how many must be here? There is 250 already. So you need to be 800 here, right? Now the total of the brown is 1200. So there should be 400. Okay, let us find out the total here too. 400 plus 300 is 720. 720. Okay, so we completed the table. That was the first problem. Form a table for the given information. Okay, let's answer the that is number I. Okay, let's answer double I. It says that in double I, it says if a person is selected randomly, find the probability that he has a black hair color or red hair color. Probability of black, or let me write black or red. So what is the formula? Do they have anything in common? Black hair color. Black hair color is this. Red hair color is this. There is nothing common, right? The people who have black hair color, they do not have red hair color. So this is disjoint, right? So probability of black plus probability of red, right? So what is the probability of black? It is 500 over. Oh, by the way, what is the total? 1050 plus 720. You can add that or add this way. Okay, that will be 1770. The total is 1770 here. Okay, so probability of black is, the total number of black is 500 divided by total number of the people is 1770, plus probability of red is 70 over 1770. Okay, if you do that, you will get 570 over 1770. That's the answer. How about the triple I? Triple I is if a person is selected randomly, find the probability that he has brown hair color. What is the probability of brown hair color? Brown hair color. Probability of brown is 1200 over 1770. That's it. And the next one I want to do is IV. Okay, probability of if a person is selected randomly, find the probability that he has black hair color or blue eye color. Black hair, let's say BLH, or blue eye, BLE, blue eye color. Okay, what is the probability? Do they have anything common? Black hair color or blue eye color. This is common thing. You see that? That is the common. So they have common. Black hair is this column, blue eye is this row, right? So they have 200 in common. So how do I do that? We need minus A and B. We need to subtract that, right? If they have common. So that will be P black hair plus P blue eye minus of black hair and blue eye, right? That's what you do. So what is the probability of black hair? Is 500 over 1770 plus blue eye is 1050 over 1770. Okay, minus black hair and blue eye is 200 over 1770. You see that? What do you think the answer is? The answer is 500 plus 1050 is 1550 minus 200 is 1350, right? Equals to 1350 over 1770. So this is how we find out the probability of A or B if they have anything common, joint, or nothing common, disjoint. Okay, we have two different formula. For the joint we have PA plus PB. For the disjoint we have PA plus PB minus the common, the probability of the common. Okay guys, this is what we do. In the next video we will be doing the independent events, multiplication rule, and conditional probability. Okay guys, thank you.